So this is part 3 of our video series. We're going to look at multiplication and division with decimals. So right now I just want to look at some patterns. So if we looked at, 1 times 50, we get 50 as an answer. 1 times 5, we're seeing we get 5, and I could bring in some 0 placeholders as well. And then if we multiply 1 by a decimal, we're going to see that now we're starting to get smaller. And so we basically are multiplying by 50 and then 10 times smaller than that, which is 5, 10 times smaller than that, which was 5/10. So now we're seeing that we're going to get smaller and smaller. So notice that a whole number multiplied by a decimal, notice the result. Same thing here. We got 2 multiplied by 250, we got 500. 2 multiplied by 25, well, that's smaller than 25, or 250. So we're going to get 50 as an answer there. And then 2 by 2.5, or 2 5/10, we're going to see we're getting smaller. 2 multiplied by 25 hundredths. Now we're seeing we're into the smaller than 1. And then 2 multiplied by 25 thousandths, we're going to see our results. So just looking at some patterns, and it's good for students to be able to look at patterns, and you can use calculators for this if you just want to model something so they're not spending the time by hand. They're just looking at what that result would be. Okay, so that would be 1,000. And then this would be 100. And this would be 10. So they're seeing that that would be 1. And that would be 1/10. So what patterns are you noticing when multiplying by decimals? It is just to notice that your results are getting smaller. And so every time we multiply a whole number by a decimal, we know that we're going to get a smaller amount. So we're going to look at just a couple of problems here with different strategies. So with the front end estimation, we're going to look at 3 4/10 multiplied by 2 6/10. So we're going to see that that's approximately 3, approximately 3. So we multiply that, we're going to get approximately 9 as an answer. And we know we rounded one of them up and one of them down. So we know somewhere around 9. So let's think about the base 10. Okay, so now we're doing 3 4/10 multiplied by 2 6/10. So if you had some struggles with the base 10 set up with whole numbers, now hopefully this will be just another view, another example of it. But then you're not using this. Remember, your flats represent 1, your rods represent 1/10, your units represent 100th. So what we're going to do is we're going to build 3 4/10. So there's the 3 flats, 1, 2, 3, 4/10. So along this side, we had 3 4/10. And now along this side, we need to show 2 6/10. And so what are we going to do? Well, we're going to fill in with the flats and the rods. And then we'll notice that this rectangle here would be a 6 by 4. So what we'll have are 24 of our hundredths, the unit cubes representing hundredths. So there's the 24 hundredths would represent here. In orange, we see that we're going to have 1, 2, 3, 4, 5, 6. So we're going to have 3 groups of 6/10. So that should be 18/10. or 1 8/10. And then here we've got 4, so we've got 8/10 here as well. And then we've got the six flats plus the 8/10 plus the 1 8/10 plus the 2400ths. We add those up. We're going to have 8 8400ths as our answer for the base 10 model. All right, let's look at the area model. So make your rectangle. And we're going to have this representing 3, this representing 4/10, this representing 2, this representing 6/10. So 3 times 2 is 6. 2 times 4/10 would be 8/10. 3 groups of 6/10 is 1 8/10. 6/10 times 4/10 is your 2400ths, which are all your partial products. So add each of the area models together, and you'll see that we get the 8 8400ths again. We look at the partial products, so 3 4/10 multiplied by 2 6/10. So this is the 6/10 multiplied by the 4/10, so that's going to be 2400ths. And then the 6/10 multiplied by 3, so again, there's your 3 groups of 6/10, which would be 1 8/10. And then we've got the 2 multiplied by 4/10, which is your 2 groups of 4/10, which is 8/10. And then the 2 by 3, which gives you the 6. Add those up, you're going to get 8 8400ths. Then if we look at our fraction model with the same numbers, so we're going to have 3 4/10 multiplied by 2 6/10. Well, 3 4/10 is the same as 34/10. 2 6/10 is the same as 26/10. So if you see that 10 by 10 there, that's going to give you 100. And then what's 34 multiplied by 26? Well, that's going to give you 884. And so now you have 884 hundredths. So if you say the fraction, you can really write the decimal, 884 hundredths. 884 hundredths. So here's your number that when we divide by 10, our number slides to the right because the place values get smaller to the right on the place value chart. So if we divide by 10, we get 88 4/10, divide by 10 again, and we get 8 84 hundredths. That leaves you the standard algorithm. So 3 4/10 multiplied by 2 6/10. So again, this is tied to your fraction model. You know that this front end here of 3 times 2, we know it's going to be somewhere around 6. So if we multiply 34 by 26 like we did over here, we know we're going to get something that's 884. So what we could do is multiply it normally, but just know that we're going to have to divide by 10 and 10 again. So when we do this as a normal algorithm of a 2 by 2, and add up everything, we know it's not going to be 884 because we're dividing by 10 and dividing by 10. So when we divide by 10, the decimal ends up being at 88 4/10. But we divide by 10 again, the decimal lands in the spot of 800 or 8 84 hundredths. So the number does slide to the right. every time that you're dividing by 10, just like it slides the other way. Every time you're multiplying by 10, you're getting larger, but you're only getting larger when you're taking a whole number or even a decimal amount. I want you to think about where, when it's moving in this direction, because you're dividing by 10. When you're multiplying by 10, so if we take 8 and 84 hundredths and multiply it by 10, well, we've just created a number that's 10 times bigger than 8 and 84 hundredths, which is 88 and 4/10, because the number had to move to the left, because to the left is larger on the place value chart. Okay, so let's look at another one. David studied for 4.5 days for 3 7/10 hours each day. Let's look at the front end estimation with this. So 4 5/10, 3 7/10. So that's about 5. That's about 4. So we know somewhere around 20 hours. I rounded them both up, so we know we're going to be somewhere less than 20 hours. So it gives the students a chance to think about thinking about what the estimate answer would be. All right, so let's go to the base 10 blocks. And sorry, that's where I was. And I lost my place here, because I think I deleted it. So there I was, right there. Okay. So now let's look at 4 5/10, and let's multiply that by 3 7/10, and let's use the base 10 blocks to model this. Okay. Now we only have so many, we can only model this really into the hundredths. So it is a limited model with this. We're not going to model this with thousandths, but we can give the students a model of what this would look like of 4 5/10 and 3 7/10, because we know our answer is going to show us into the hundredths. So let's build the 4 5/10. So this section shows 4.5, and this one's going to show 3 7/10. And then again, we're just going to fill in with the flats. We said this answer was somewhere around 20 or less than 20. Well, I'm already seeing 12 here with the flats. So I'm just going to continue to fill in. And then just know that my last rectangle here in the hundredths should show 5 by 7 or 35 hundredths. So when we split all that up, we would see 35 hundredths. Okay, so what's next? We've got all of these, right? Well, that's 7. We got 4 groups of 7/10. 4 groups of 7/10 would be 2 8/10. And then here I've got 5, 10. We've got 15 tenths, or 1 5/10. And then last we have 4, 8, 12 flats. So we're going to have the 12 flats, 1 5/10, 2 8/10, and the 35 hundredths. So 13, 30, 16, 2, 3, 4, 5, 6, 16, and 65 hundredths, which is a little bit less, just a little bit from the 20 that we approximated. So that's building your 4 by 5, your 4.5 by 3 7/10 rectangle. So let's do the same, 4 5/10 multiplied by 3 7/10. Let's look at the area model. So build your rectangle. We know this will be 4, this will be 5/10, this will be 3, this will be 7/10. So 4 times 3 is 12. 3 groups of 5/10 was 1 5/10. 4 groups of 7/10 was 2 8/10. 5/10 by 7/10 was 35 hundredths. Again, add everything, add all of your areas up. And we'll get 16 65 hundredths. Let's look at partial products. So we're going to multiply the 7/10 multiplied by the 5/10 to give us the 35 hundredths. We'll multiply the 7/10 multiplied by 4, which will give us the 2 8/10. Multiply the 3 by 5/10 to give us 1 5/10 or 1 50 hundredths. And then the 3 by 4, which is 12. All of those numbers you saw in the base 10, all of those numbers you saw with the area model. We should have 16 65 hundredths as our answer. We do the same thing with the fraction model. We could say, well, that's 45 tenths multiplied by 37 tenths. 10 by 10 is 100. And we know that if we multiply 45 by 37, we're going to get 1,665. So what happens when we divide that by 100? Again, you're going to shift your number every time you divide by 10. So now it's 166 5/10. And then when you divide by 10 again, you're going to get 16 65 hundredths. And so that's your fraction model. And then last, if you want to look at the algorithm, very similar to the fraction model. So I would just multiply this normally, just like you would with your standard algorithm with multiplication, but we know that answer is not going to be 1,665. So we notice that we have a tenth, which, how did we get that? We took 45 and divided it by 10. So we need to divide this number by 10, and we know that the decimal point would end up there. But we also see that with 37 divided by 10 gives us 3 7/10. So we need to divide it by 10 again. So that's going to give us the 16 65 hundredths. So the nice thing with getting to the standard algorithm is again, it's a goal. It's a goal after you can show how the base 10 works, how the area model works, how even before that, thinking about an estimate, and then showing some patterns of what happens when you multiply a number like 7/10 and 5/10. And we see that we get something much smaller than 7/10 and 5/10. We get 35 hundredths. What happens when you take a whole number 4 and multiply it by 7/10? You get something smaller. So that's the goal with, and you want kids to recognize is that when we are multiplying by a whole number by a decimal, or even a decimal by a decimal, that we are going to get a smaller value. Okay, in our last part, we're going to look at some examples with dividing decimals, and then we'll look at two examples using the different strategies, and then we'll wrap up the video. So when you're looking at patterns like this, you're thinking, all right, this is 1 5/10 divided by 7/500. You're thinking, how many times will 7/500 divide 1 5/10? And that will end up being 2 times. You can also think, well, how many 75 cents will fit into $1.50? 2 groups of 75 cents. Here you're thinking, well, how many 3 hundredths will fit into 27 hundredths? Well, it's 9 groups of 3 hundredths. How many 25 cents will fit into $1.25? That'd be 5. How many 25 cents or quarters will fit into $2? Well, that'll be 8. And how many 4/10 will fit into 3 6/10? And that would be 9 times. If you'll notice, look at all the results. They're larger. They're larger than what you started with. Very similar to the idea with dividing fractions. So when you're dividing the decimals, notice that if you turn this around, like on part E, you're just thinking, well, 4/10 multiplied by something is going to be 3 6/10. Well, that something is 9. Well, 9, which is a whole number, multiplied by something smaller, we ended up with something smaller. But when we look at the division, we're going to see that we actually get something that's a little larger when we're doing division with decimals. So let's take the first one, and we'll look at 2 different example types here. So we're going to start with 4 83 hundredths divided by 2 1/10. I'm going to approximate that to about 5, and this to about 2. Half of 5 is about 2 1/2. So we'll just say somewhere about 2 1/2. 2 to 2 1/2. Some of you may have thought, well, what about just 4 and 2? Would that work? That would work too. That would put you around 2 as an answer. Now with the base 10, you've got 4 83 hundredths divided by 2 1/10. You're going to start with all of this. So we need to go ahead and lay out the 4, the 8/10, and the 3 hundredths. And what you're going to do is you're going to build one side that's 2 1/10. So let's build this side as 2 1/10. Well, as I build it, I can't forget, I have to take these away. So what am I left with? I'm left with 2 flats. 1, 2, 3, 4, 5, 6, 7. 7 of the rods and 3 hundredths. So now it's just a fill in. I'm trying to figure out 2 1/10 multiplied by something is equal to 4 83 hundredths. So as I'm building this, I'm going to use 2 more flats. And I'm done there. And then I know I have 7 rods left. So I'm going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I've got 1 left. I'm going to place it right there. And then that's going to leave this one for these 3. And then I've used everything, which means no remainder. So this side is 2 1/10. This side is 2 3/10. So again, start with the dividend. Start with 4 83 hundredths and build it. And that's what we did here. And then what are we doing with the divisor? Well, that becomes one of the sides. So you end up trying to figure out what's the other side. So you use up all of your pieces, then you know you don't have a remainder. If you possibly have a piece left over, then you know it wouldn't divide evenly. All right, so let's take 4 83/100 divided by 2 1/10, and let's look at the fraction model. So we would have 4 83/100 divided by 2 1/10. That's the same as 483/100 and 21/10. So I'm just thinking I'm going to try to make these the same. So 483/100, what would I have to multiply 21/10 by? I'd have to multiply it by 10. So 210 divided by 100. 21 times 10 is 210. 10 times 10 is 100. So what's 100 divided by 100? That goes to 1. So what are you left with? You're left with 483 divided by 210. And so we want to see, well, that will divide twice. 210, two groups of 210 would be 420. So that leaves me with, may have to bring a 0 placeholder there. 210 will divide 63, just not a whole amount of times. It would be 3/10 times with the remainder of 0. This is a good strategy. It's just not used very often because you want to get the denominators the same, which means you might have to multiply the divisor by some multiple of 10. Then you got the standard algorithm. So we've got 2 1/10. How many times will 2 1/10 divide 4 83/100? So your goal for the standard algorithm is to make the divisor a whole number. So that's 2 1/10. So 2 1/10 multiplied by something to get 21, because 21 would make it a whole number. Well, I just need to multiply it by 10. So if I multiply the divisor by 10, then I also need to multiply 4 83/100 by 10. So this will make this 21, and this will make this 48 3/10. Now I can go through my standard division, and this would divide twice. So that would be 42, and then 21 will divide 63, 6 3/10, 3/10 times, and you get a remainder of 0, which is what we saw that the answer was earlier. So there's your different methods. Excuse me. All right, so let's look at one more example. We're going to take 7 36/100 divided by 3 2/10. And you can approximate this to maybe around 6, this one around 3. So you know your answer is probably around 2. So then let's look at the base 10. What are we going to start with? We're going to start with the dividend. So we want to build the dividend. So we have the 7 36/100. 7 flats, 3 rods, 6 units. And so we want to build the other side to be 3 2/10. So we'll just go along the side here and make that 3 2/10. So once I build it, I've got to scratch it off. And notice that that's going to leave me with 4 flats, 1 rod, and 6 units left over. So again, we're just going to fill in from there. And so this is a good opportunity if you wanted to. This one's not going to have a remainder. as you could tell your students, this one's not going to have a remainder. So you know you're going to use up all of your pieces. So then, as they're getting into this and practicing this, it'd be a good idea to start without remainders, and so they get a feel of it. And so I know I've got 4 remaining. So I'm going to finish with 3. So 1, 2, 3. And then I see I've got a flat and 1 rod. So I'm going to have to do some decomposing here and regroup 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So now I actually have 6 rods and 6 units left. So I know I've got to fill in these 2. So I'm going to take that one off up there and this one off here. And then I'm going to try 1, 2, 3, 1, 2, 3, another 1, 2, 3, 1, 2, 3, and then notice I have 3 left. So that should fit just perfectly there. And then what's going to fit here is a 3 by 2. And that's 6, and that's what I have here. So I would not have a remainder. This would be a 2 by 3. And so we've got 6 hundredths here. And then in yellow here, we've got, so we've got 1, 2, 3, 6, 9. We've got 9 tenths. And then here we've got 4 tenths. And then of course we've got our flats. So we're going to have 6 holes. And we've got 4 tenths. And then we've got 9 tenths. And then we've got 6 hundredths. And so that's just showing that that should model back to where I started. But since this is what we began with, was 3 2/10, what was our side over here? I'll erase this so we can see it. This was 2 3/10 long, so that's what we were looking for. So 2 3/10 multiplied by 3 2/10 gives us the 7 36 hundredths. So let's do the same thing with the fraction model. So I've got 7 36 hundredths, which would be 736 hundredths divided by 3 2/10, which would be 32 tenths. And so I just need to multiply this by 10. So 736 hundredths divided by 320 hundredths. These will divide out, and you're left with 736 divided by 320. And I may have to put a couple 0 placeholders for the tenths and hundredths place, but I know that that's going to divide twice. So that'll be 640. And that'll be 96 0/10. And that should divide, so 3/10 there, remainder of 0. And then your standard algorithm, remember your goal is you want this 3 2/10, you want it to be a whole number. So I'm going to multiply it by 10, which would make it 32, but I also have to multiply the dividend by 10, which would be 73 6/10. So we know that that's going to divide twice to make 64, and that'll be 9 6/10, and that'll be 9 6/10 with the remainder of 0. So let's look at one more, just what happens if we had something like this. You're trying to see how many times will 1500ths divide this. Well, in order to make 1500ths a whole number, I've got to multiply it by 100. What I do to the divisor, I also have to do to the dividend. So that's going to make it 48 6/10. So 15 will divide 48 3 times, so that'll be 45. So we see we're going through the same process as with our whole number division algorithm. And so that will divide, 15 will divide 3 6/10 2/10 times, which would be 3 0/10. So that would be 6/10. I just need to bring another 0, add a 0 placeholder there in the hundredths. So now how many times will 15 divide 60 hundredths? Now it should be 4 hundredths times to be 60 with the remainder of 0. Point I wanted to make there is that if you had to, we kind of, the last examples, we were multiplying by 10 with the divisor. Here we needed to multiply by 100. Don't forget, you got to do the same thing with your dividend. So this concludes video 3, where we looked at multiplication and division with decimals.